Welcome to AI Frontiers, where we explore the most groundbreaking research shaping our technological future. Today we're diving into 55 cutting-edge papers from December 2025 that are fundamentally transforming computational linguistics. These aren't just incremental improvements to chatbots or translation apps. These are breakthrough discoveries that are redefining how machines understand, process, and generate human language, with real-world applications spanning healthcare, education, and beyond. Picture this remarkable moment we're living in. Right now, as you listen to this podcast, an AI system somewhere in the world is reading a child's dental records, cross-referencing medical databases, and recommending the safest antibiotic dosage, all in the time it takes you to blink. Another system is scanning millions of web pages per second, organizing human knowledge at a scale that would take armies of librarians centuries to accomplish. And yet another AI is peering inside its own digital brain, watching its thoughts form, trying to catch itself in the act of making things up. The boundary between human and machine understanding of language isn't just blurring, it's being completely redrawn. What exactly is computational linguistics, and why should you care? Think of it as the Rosetta Stone project of the digital age. Just as that ancient artifact helped decode Egyptian hieroglyphs, computational linguistics is helping us decode the most complex communication system we know, human language. This field encompasses everything from parsing sentences and understanding grammar to maintaining context across long conversations, detecting subtle emotions and biases, and generating responses that are genuinely helpful and safe. Every breakthrough immediately impacts millions of people through the AI systems they interact with daily, from voice assistants to medical diagnosis tools, from educational platforms to creative writing aids. Imagine language as a vast, ever-changing ocean. For decades, researchers have been building better boats to navigate this ocean. First, simple rule-based systems that could barely paddle around the shallows, then statistical methods that could venture into deeper waters, and now large language models that can surf the biggest waves with remarkable skill. But here's what's fascinating about today's research. We're not just building better boats anymore. We're learning to read the currents, predict the storms, and understand the very nature of this linguistic ocean itself. This represents a fundamental shift from brute force approaches to elegant understanding of language dynamics. The first major theme reshaping the field is what researchers call the safety revolution. As language models become more powerful and widespread, ensuring they behave safely and ethically has become paramount. Think of it like teaching an incredibly gifted but inexperienced intern who has read every book in the world, but doesn't always understand the real-world consequences of their words. Multiple breakthrough papers tackle this challenge from different angles, preventing models from forgetting their safety training when learning new tasks, detecting and correcting biases across different cultures and languages, and developing frameworks for maintaining ethical behavior even when exposed to potentially harmful data. This isn't just about preventing obvious problems like generating harmful content. It's about ensuring AI systems understand the subtle cultural and contextual factors that make communication appropriate and helpful. The second theme centers on what researchers call the reasoning challenge. Here's a provocative question. When a language model explains its reasoning, is it actually reasoning, or is it just very good at mimicking the patterns of reasoning it saw in its training data? This question goes to the heart of whether current AI systems truly understand what they're saying, or are simply sophisticated pattern-matching machines. Breakthrough research is developing new ways to test genuine reasoning abilities, creating more structured approaches to complex problem-solving, and building systems that can verify and validate their own reasoning chains. The implications are enormous because if we can crack the code of genuine machine reasoning, we'll have taken a giant leap toward artificial general intelligence. The third and fourth themes involve the personalization and cultural awareness revolution alongside the efficiency breakthrough. As AI systems become global tools, researchers are creating culturally sensitive and personally relevant systems without losing core capabilities. Picture a universal translator that doesn't just convert words between languages, but understands cultural context, personal preferences, and the subtle ways meaning changes across communities. Simultaneously, with the enormous computational costs of training large language models, researchers are developing ingenious methods to achieve better results with less computing power. Instead of just making models bigger and more power-hungry, they're finding smarter ways to organize information, more efficient learning methods, and clever approaches for combining multiple specialized models. Now, let me share the most groundbreaking discoveries that emerged from this research. Findings that represent potential turning points in artificial intelligence development. First, researchers solved the catastrophic forgetting problem in AI safety using dark experience replay, allowing models to learn new skills while maintaining ethical guardrails. Second, workflow-based generation approaches show that previous generation models using smart architectures can outperform much larger, newer models using traditional methods. Third, comprehensive cultural bias studies reveal surprising patterns that don't align with training data expectations. Fourth, new text processing systems achieve 3 to 100 times speedup over neural baselines, while maintaining comparable quality. These aren't just incremental improvements. They're discoveries that could fundamentally change AI development trajectory. For our paper of the day, we're exploring research that perfectly exemplifies the intersection of technical innovation and real-world impact. Knowledge-guided large language model for automatic pediatric dental record understanding and safe antibiotic recommendation by Han and colleagues. This isn't just another incremental improvement to language models. It's a comprehensive framework that tackles one of the most challenging applications of AI in healthcare while maintaining safety standards that could literally save lives. Every day, pediatric dentists face complex decisions about antibiotic prescribing, requiring careful consideration of age-specific dosing, potential allergies, drug interactions, and developmental factors. The stakes are high. Underprescribing can lead to serious infections, while overprescribing contributes to antibiotic resistance and harmful side effects in developing children. The technical approach developed by Han and colleagues is elegantly sophisticated. At its core is a knowledge-guided large language model that integrates 3 key components: a pediatric dental knowledge graph containing structured clinical guidelines and safety rules, a retrieval-augmented generation system that pulls relevant information from this knowledge base, and a multi-stage safety validation pipeline that checks recommendations against known contraindications. The system first uses clinical named entity recognition to identify key information like patient age, symptoms, medical history, and current medications. This structured information queries the knowledge graph to retrieve relevant clinical guidelines and similar historical cases. The experimental results are clinically meaningful. The system achieved an F1 score of 0.914 compared to 0.867 for baseline models, improved drug dose duration accuracy from 0.716 to 0.782, and reduced unsafe antibiotic suggestions by 50%. What makes this research particularly compelling is how it balances innovation with safety, prioritizing clinical appropriateness over raw performance metrics. The researchers could have simply fine-tuned a large language model on dental records, but instead recognized that healthcare applications require a fundamentally different approach. The dual-layer safety validation mechanism combines deterministic rule checking with learned classifiers, ensuring multiple different types of potential problems can be caught before reaching patients. The human element is particularly striking. Dr. Han spent months working directly with pediatric dentists to understand their workflow, decision-making process, and concerns about AI integration. This wasn't technologists building in isolation, but collaborative effort to create tools that genuinely enhance clinical practice. The significance of this work extends far beyond pediatric dentistry, demonstrating a methodology for safely deploying language models in high-stakes clinical environments, where errors have serious consequences. The integration of structured knowledge, multi-stage validation, and careful evaluation provides a template applicable to other healthcare specialties and high-stakes domains like legal advice or financial planning. One fascinating aspect is how the system handles uncertainty and edge cases. Rather than trying to make the AI omniscient, researchers designed it to explicitly acknowledge when encountering situations outside training data or when multiple treatment options might be appropriate. This humility is crucial in healthcare applications, where overconfident AI systems can be more dangerous than helpful ones. The interface presents information in familiar formats and integrates with existing electronic health record systems, making adoption seamless. Looking toward the future of computational linguistics, the research points towards several exciting directions that could reshape how we interact with information and make decisions. The first major direction is hybrid intelligence systems, AI that doesn't replace human reasoning but augments and enhances it. Think of the evolution from calculators to smartphones. Early calculators automated arithmetic, but smartphones created entirely new ways of thinking by seamlessly integrating multiple capabilities. The workflow-based generation and knowledge-guided systems represent early steps toward AI serving as genuine intellectual partners. The second direction involves democratizing advanced AI capabilities across languages, cultures, and domains, making sophisticated language AI available to communities previously left behind by English-focused, high-resource scenarios. The third direction is truly interpretable and trustworthy AI systems that help us understand their reasoning, acknowledge limitations, and provide confidence estimates. The fourth direction involves integrating AI with real-world time-dependent processes. Advances in multimodal temporal understanding suggest we're moving toward AI systems that understand not just what we say or write, but how language relates to the physical world, to time, and to complex situation dynamics. This could revolutionize everything from robotics to education to scientific research. As we've discovered together, we're witnessing AI systems learning to maintain their ethical principles while acquiring new skills, researchers uncovering the true nature of machine reasoning, and engineers building tools that can safely assist in life-critical decisions. These breakthroughs represent the foundation for genuine human-AI collaboration, where artificial intelligence serves as an intellectual partner rather than just a sophisticated tool. This research summary was created using AI synthesis with Claude Sonnet 4202-50514, TTS synthesis powered by DeepGram technology, and visual generation through OpenAI systems. Human expert review was conducted with acknowledgement of potential oversights, and all original research references are provided for verification. The synthesis process involved analyzing 55 papers from the archive preprint server to identify key themes, breakthrough discoveries, and practical implications for the field of computational linguistics. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily.